Hello. I think everybody's coming, joining the class right now. We'll wait a minute or two, make sure everyone arrives. I'm going to go ahead and start. Screen sharing. Okay, you should see my desktop right now. Okay. Waiting to make sure everybody is here before we really get started. Here's the entry for today's class. Okay, and mostly it's let's see. Okay, just setting everything up. Okay, there'll be the video here, and there's a reading assignment for. First of all, it's real important. There's a new programming assignment. Okay, so we'll look at that in a second. There's a new programming assignment, and there's a reading assignment for the rest of the week. So we're going to start talking about chapter 3. Probably won't start it today, maybe, but we'll definitely on Thursday we'll be talking about this chapter 3 from this book. Chapter 3 is something called the scanner class. And the other book also has a reading about the scanner class. So I kind of gave it to you. There's two readings. This one about the scanner class, and then this other book also has a reading about the scanner class. Okay, so there's two readings. They're about the same thing. So you read it, yeah. And this was actually already assigned reading. This was from chapter 1 of the other book, but you might want to read it again, compare it to this chapter 3 of this book. Okay, so two parallel readings, both about the scanner class. The scanner class is how we're going to, how a program can ask the user to enter numbers into the program using the keyboard. It lets a program read from keyboard input. Okay, so that'll be what we'll talk about on Thursday. Today, we're going to talk about this reading assignment from last week. We're going to look at these two sections here in the book. And last week, we did this example about variables. This reading assignment was more about variables. But actually, I want to go back to this example here. Okay, this is what we did last Thursday. We did this example. Right now, it's up on the course website. So this is a file up on the course website. If you download this file, you can save as. You can download it to download it to my desktop as a Java program. So I'm downloading it. See, it's right here. So I downloaded it from the course website to my computer. Now it's on my computer. If I want, I can open it in Dr. Java. Dr. Java is a little bit slow, but there's Dr. Java, and I can open this file in Dr. Java. Okay, and of course, you can compile it. Well, see, Dr. Java is kind of slow. Let me close that. I'm not sure what's going wrong with Dr. Java here. Okay, let me try this one. Okay, run Dr. Java. I can open this file in Dr. Java. It's the same file that was up on the website. I can compile it. Okay, it's compiled. Now, after it's compiled, notice that gave me the class file, and I can run it. I get lots of output in this output window. Okay. Now, we stepped through this file in class the other day. We wrote this while we're talking. Now, what I want to do is I want to show you another way to run this program that we're going to be using, that we're going to do a lot. We're going to go back to the website. Okay. Here's that file. What I'm going to do is, instead of saving it, I'm going to highlight it. There's the file. I'm going to copy it. And I'm going to open another tab on my browser. And I'm going to go to something called the Java Visualizer. Okay, this is a website that we're going to be making use of quite a bit in this class. This is a version of Java that runs over the internet that lets you, we'll see what it lets you do. So I want to put my program in this editing window here is just like Dr. Java's editing window here. Okay, now it comes kind of preloaded with an empty Java program. I'm going to delete the empty Java program and I'm going to paste in my Java program. Okay, so now I've got my Java program that, it's here on the course website. I downloaded it and opened it in Dr. Java. Now I cut and pasted it into the Java visualizer. Now, in Dr. Java, I would click on compile, then run. After I compile it, I can click on run, and I get the output down here. In Java Visualizer, you don't have a separate compile and run button. You have something called the visualize button. You click on the visualize button, and you get something that's really useful, something that's real important. This lets us watch our program run step by step. Unlike Dr. Java, which just when you click run, the whole program just runs all at once. See, it just ran all at once and all the output appeared at once. Dr. Java, what Dr. Java did is it ran this program step by step through all these lines, but really fast. This program lets me step through my program one step at a time. So my program starts here with line 6. They skipped over line 5 because line 5 is just a comment. And line 6 creates a new variable. Okay, see, it's a declaration. Then when I click forward here, what I see is the right half side of this program shows me my variables. So it shows me that when I created a variable in line 6, this Java visualizer shows me, well, you now have a variable called m that holds the value 5. See, it created my variable m with the value 5. And right now, I'm about to execute line 7. So this 7 right here is telling you that you're in the main method. I'm in the main method. I'm at line 7. I'm at line 7. 7's highlighted in yellow. So far, I have one variable. That's this variable from line 6, and it holds 5. Now I'm about to print something. When I print something, it appears down here. See, down here is program output. Just like Dr. Java shows its output down here at the bottom, this program also shows its output down here, but I have to step through line 7. So I click forward, and I just did line 7. I'm about to do line 8, and I see the output from line 7 down here. See, I'm stepping through my program. Instead of my program happening all at once, I get to watch my program execute line by line. And I get to see the variables over here. So like right now, this box that holds the variable is going to change its value because this says copy 2 into that box. So now that box holds 2, and then I print out the new value of that variable. Now I'm creating a new variable. So I got a new box called B, which holds the value 3. And then I could print it out. Okay, so I'm seeing my output down here. Okay, now I keep stepping through. The next thing is I'm going to, now the visualizer skips over line 14 because line 14 would create an empty box over here. And I guess the designers of this didn't like showing an empty box. So when I click next, it'll skip over line 14. Line 14 is really there. It actually creates a box called X that's empty. Then line 15 puts 0 in it. Okay, now notice it skipped over line 14, and it doesn't show you the empty box. I think that's kind of a bad choice on their part. I think they should show you the empty box that line 14 created. So there should be a box called X, and there's just nothing in it right now. That's actually what Java is really doing. At line 14, we created an empty box. Line 15 puts something in the box, but this thing shows you as the box being created there. Line 14 created the box, but it's empty. Line 15 puts something in the box. Okay, and then we print out the content of the box. Now notice I'm starting to run out of space down here. I have to scroll down a little bit to see the extra output. So if I scroll down here, I can see a little bit, I can see the output here. Then if I scroll here, notice there's a lot of windows within windows. This lets me scroll my code. This lets me scroll the whole output window. Okay, so I want to see more output and I want to see more of my code. Okay, so I'm at line 17. I'm about to execute line 17. Line 17 was the thing that said x is x. It put that, line 17 wrote a little equation. Okay, all right. Now I create a variable that's a float variable. Okay, see, it holds those decimal places. Okay, and then this one holds a double. Doubles can hold more decimal places than floats. Remember, that's what we were talking about, how it's called double because it holds twice as many decimal places as float. Okay, so there's twice as many decimal places. You can't add more decimal places to W. W doesn't have room for more decimal places. It's limited to about 8 decimal places. And floats are limited to 16 decimal places. So if I typed more numbers at the end of 7, they wouldn't show up here. If I typed more numbers after the 8 here, they wouldn't show up here. Okay, so there's floats and doubles. So that's what they look like. Then I can print out the float and I can print out the double. Okay, now I'm at line 23. Notice I'm watching my program execute. Every time I click forward, just like a little play button on a remote control. This step, you can actually go backwards too. Now, when you go backwards, it undoes the variables, but it doesn't undo the outputs. Notice that the outputs did not get undone when you went backwards. So, and see, there's this little slider. As I go backwards, how this slider is moving to the left. Oh, wait a minute. Oh, no, let's see. No, it is undoing the outputs. I didn't realize. Yeah, it is undoing some of the outputs. Okay, so going back undid outputs, going forward redoes everything. Okay, so you can step through your program forwards and backwards. This is really useful, especially if you're trying to figure out why a homework assignment isn't doing the right thing. When you're working on homework assignments and you can't figure out why it's not doing what you want it to do, you can copy and paste your homework assignment into the Java visualizer. Just like I copied from here to here, you can copy from Dr. Java to here, and you can run programs in the Java visualizer and see what they're doing. A lot of times, as we'll see as we go through the semester, that can help you figure out what you might be doing wrong. When a program doesn't do what you think it should be doing, instead of it just flying by you and you're wondering what it did, the Java visualizer lets you what we call single step. You single step your way through your program and you can watch what it does. Okay, so now notice I'm down here. Remember we talked about integer division versus decimal division, how this symbol doesn't mean the same thing as this symbol, because this symbol has 2 ints on either side and this symbol has 2 decimal numbers on either side. This does quotient. How many 2's are in 5? There's 2 2's in 5, so notice that y holds 2 because there are 2 2's in 5. Now I'm changing to this other kind of division. Now y holds what you expect it to hold, 2.5, because now I did 5 divided by 2, but with regular decimal division, and I get 2.5. So notice that integer division asks how many 2's go into 5. Decimal division does what your calculator does. It computes 5 divided by 2, which is 2.5, 2.5. Okay, all right. So I want you to see that you can step through programs. You can use the Java visualizer to step through programs, and the program is really 3 things. This is real important for us to think about: the code, the output, and the variables. And we're going to emphasize this a lot. The code, when you think about code, you should, in your mind, be thinking that there's the code that the computer steps through. As the computer is stepping through the code, it does 2 things: updates variables and sends output to the output screen. Okay, so your program, these commands send output to the output screen, but these assignments and these declarations change the variables over here. Okay, and as you learn to program, you learn to think in terms of this 3 parts of you learn to think that a program is these 3 pieces: code, variables, and output. In Java, in Dr. Java, you don't see the variables. You don't see how the variables are changing as the program executes. That's why they invented the Java visualizer. The Java visualizer was invented to let you see these three things. And I wish the Java visualizer is much newer than Dr. Java. If they ever update Dr. Java, my guess is it will get a third part to it, which is like the Java visualizer, something that shows you the variables. Dr. Java does have a way to do this, but it's not very nice. Later on, we'll see that Dr. Java will let you watch your variables, but in a not especially pretty way. So the Java visualizer, what it does well is it lets you watch the variables in a really nice way, your code, your variables, and your output. Later on, we'll see that Dr. Java will let me watch my output, my variables, but not as nicely as the visualizer does. Okay, so we'll see that later on. So to use the visualizer, you have to go to the visualizer website, and if you just Google Java visualizer, you'll get its website right away. They put a little bit of boilerplate code in there, so you can actually just type something like, so you can just type so they already have enough code in there that you can just type a piece of Java, and you can visualize it, and you click forward, and what it did is it created that variable X. That's all it did, was create a variable X whole 56. So the visualizer comes up with if I reload the page, see, it comes up with essentially an empty program with a place in it for, if you want to, you can type code. Or you could, if you want, delete what's in there and paste in something else. You could paste in a whole program. Like over here, if I select everything here, I can copy, go over here, paste, and now I have a whole program. You can copy and paste program from the online textbook. If you're reading something in the textbook and you want to try it, you can paste it into the Java visualizer. Okay, so the Java visualizer doesn't really care where things come from. It lets you you can paste your code into the Java visualizer, then visualize it. Okay, all right. So I wanted you to see, we're going to be using that more and more. Okay, we're going to be using that kind of a thing fairly often. Okay, now actually, let's go look at the homework assignment. Before starting to talk about these sections here, let's look quickly at the homework assignment. Here's assignment 2. Every assignment has a page that describes it, which you read carefully, and a zip file that you download. Okay. Okay, I downloaded the zip file. Unzip it. Don't work inside the zip file. Don't double click the zip file and work inside of it. I'll keep mentioning this for a while because people it's an easy mistake to make. You just double click on a zip file and it sure looks like it's ready to be used. But zip files don't work well. If you work in this zip file, you'll get strange error messages when you try to do things with Dr. Java, and you'll just get strange error messages because Windows actually doesn't like to work with zip files. So the best thing to do is unzip them, delete the zip file to prevent yourself from maybe working with it, and then work with the unzipped folder. Okay, so this is the folder. Okay, now here's what this homework assignment is. In this folder is a program called Homework Too Long that I wrote. Okay, and I'm going to run it in Dr. Java. This program, if you compile it and run it, it produces a picture, kind of a big picture. Okay, now notice that the program did that picture just by printing out every line of the picture. The program printed every line of the picture. Okay, and there's the output. Your job is to write a shorter version of this program, which you're going to put in this file here called homework2.java. You're supposed to write a short version. Now here's the sketch. The idea is to use variables to represent pieces of this output. Okay, so instead of, see how this is there, and then it's here, and here, and here, and here, and here. There's a lot of redundancy. What you want to do is something like this. Go ahead and make a string variable equal to that thing. Now somehow make use of that variable in place of this, 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 and that should make the program much shorter. Similarly, this guy appears several times in the picture. So go ahead and make another variable. Whoops, what did I do wrong? Oh, I got two quotes here. Okay, now somehow I should be able to use these two variables to get rid of the fact that they're, I should be able to replace this with t and replace this with t and replace each of these with an s. Okay, this is the variable abstraction that we saw in this file here when we did this thing about, well, we said, let's call remember we had greet, which we could reuse to greet a bunch of different people. Instead of having to say greet Bob, greet Alice, greet Jane, and have it all, this is the redundancy that a variable can get rid of. Remember, then once we had this greeting in a variable, we could change the greeting, we could translate it into a different language. Variables are abstract, excuse me. We think of variables as abstraction. We abstractly think of the idea of a greeting. That's a very good idea. So in this programming assignment, you should create variables that represent the pieces of this output, and then write code that'll use the variables so that you can write a much shorter program than this long one. So you have to reproduce the same output, but much shorter. And now, how long, let me back out of this. Let me go back to the original version. Okay, here's the original version. This program is pretty long. Here's something you can do in Windows. You right click on a file and you ask for its properties. And Java tells you how big the file is. And not Java. Windows tells you how big the file is. That file holds that many letters. It holds 2,581 letters. That's how many actual letters are in this file. If you counted them, it's a little bit tedious, but if you counted them, you can go through here and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You can count all those letters, and there's 2,581 of them. Your program should be less than 600 letters. When you are done, like right now, there's 93 letters in there. You should have a program that's only got this. You should be able to do this with less than 600 letters in your file. Okay, so you have to come up with a way of using variable abstraction to get rid of all the redundancy. There's lots of redundancy, even all these spaces. That block of spaces is exactly like that block of spaces. Okay, that block of underlines. That block of underlines appears down here. And actually, one thing to notice is this whole block here, it's exactly the same as this block here. They are copies of each other. So if you had a variable that held this whole block here, you wouldn't even need, you could just print it a second time. Your goal is to build a variable that holds this whole block so that you can print it 2 times. That's part of the trick, is to get a variable that holds this whole block in it, but it has pieces that hold this. Like this will be one piece, this will be another piece, this will be another variable, these spaces will be another variable, and then you might, for example, you might have a variable that's one line. That line is going to appear here and here and here. So you come up with names for things that you think are convenient. You should end up with a name for this whole block so that you can use it 2 times. Okay, once here and once here. Okay, so that's your homework assignment, to come up with variable names and then use them in a way that makes this program much shorter. Okay, and then I actually asked you to do something a little bit extra. This is like more of a puzzle. See how short. Oh, when you make your homework assignment should still be formatted nicely. When you're supposed to make this one shorter, when you make it shorter, you still should make it a nice readable Java program. But then I ask you to go ahead and make it even shorter by making it unreadable. So this is a game that programmers like to play sometimes. Like, here's an unreadable little bit of code. I shortened an empty program to be as short as it possibly could. The code itself would go right in there. Right in there. There's where the code goes, right there. Okay. I just got rid of all the, I got rid of all the carriage returns. I made everything in one line. The second part of the assignment is for you to like take your homework 2 and just get rid of everything that doesn't really have to be there. The stuff that's there that makes it look nice. Get rid of all the stuff that makes it look nice and get it down to just what has to be there, and then see how short you can make it. Okay, so it's just kind of a for you to see how programs have things in them that are there not for you, but or they're in there only for you, not for Java. Notice that this thing compiles. Oh, I even have an example of that in here. See this demo? This demo is, that's a program, one long line. See, that program's one long line. It's pretty unreadable. Class homework 2 short demo. Public static void main string R string A equals 1, 2, 3, 4, 5, 6, 7. B equals A plus A. C equals B plus B. D equals C. Notice how I just string out all my Java code. This compiles and it runs. And what it does is it produces an output that's one long line, but it's much long. Notice that the output's way longer than the program. Okay. So, it's like I have a short program that can produce a very long output. And I purposely made the program kind of unreadable. The program is just one glommed on line of code. And that's what I want you to do with your homework assignment. After you write your homework2.java, get rid of everything that doesn't need to be there. Like the comment at the top doesn't need to be there. The word public doesn't need to be there. You don't need these spaces here. Get rid of everything and see if you can see how short you can make your program. Play around actually, and then you might actually like on my computer, I managed to create the picture that this thing could create. Okay, this thing is 2,581 bytes long. I have a version of short that's just 220 bytes long, but it produces the same output that this one does. So I managed to shorten the long one by using lots of tricks and variables. I shortened the long one to just 220 bytes, 220 characters. So you might want to just see how short you can get yours. The homework assignment is for you to get the readable one, less than 600 characters, which isn't that hard. You shouldn't have too much trouble making your readable one less than 600 characters using variables. Then shorten it some more by making it unreadable and see just how small you can make it. Okay. So that's the homework.
I have a question about the way we format our code when we write it for the homework assignments. So for the brackets, do we have to have like the open and close, I guess you could say, brackets lining up with each other, or could we have it like public static void main string arg space?
Right. There's two
on the opening bracket, and then if you know what I mean.
There's two styles that are. One style that people use is this one, where the opening bracket is.
That's what I usually do.
Well, that's the I'll tell you. Here's what it is. That's the old-fashioned style. That style became prominent because in the old days, and I mean like in the 60s and 70s, computer screens weren't very big. So you wanted to use as few lines of code as possible.
Okay.
That style has stuck since then. People are now switching to this other style. This other style is becoming more popular. It's because now screens are very big. This style is more readable, but it uses a little bit more screen space, but it's definitely more readable. My preference is this style. I don't really care which one you use, but be consistent.
Okay. Okay.
You'll if you look around and you look at other people's code and you look at books, anything that was written 10 years ago or more will be written in the other style. Everything was in this style up until a few years ago. Then finally people realized that, boy, screens are big now. Who cares if we, this style is not as readable as the other style. So people have started switching to this style because the idea is that it makes these braces line up, which helps your eye catch things much easier. I prefer this style. I use this one all the time, but actually I don't care in your homework which one you use, but be consistent, okay? And I indent 3 spaces. 3 or 4 are common. The Linux source code uses 8 spaces, which is way too much. That's how much spacing the Linux source code does. And the Linux source code people like that spacing of 8 spaces. I don't know why they like it. Again, I think I know why they like it, because that's what computers did in the 1970s. There was a reason in the 1970s to use an 8-space indentation. That's just too much indentation. So the Linux people still use 8 spaces as their indentation. Modern people have mostly settled on either 3 or 4. I use 3. Actually, modern people are split between 2 spaces, 3 spaces, and 4 spaces. All 3 are kind of nice. I like the in-between one, 3 spaces. 3 spaces is not too much and it's not too little to me. Okay. If you look around in people's code, you'll see a lot of 2-space indentation. Well, you'll see a few people using 2 spaces and a lot of people using 3 or 4 spaces. And then the Linux people use 8 spaces. And there's nobody using anything in between 4 and 8 spaces. Okay, right? So 3 spaces, I think 3 spaces is great. 2 spaces is, 2 spaces takes up less room. Sometimes, like I say, a lot of people like 2. The majority of people use 3 or 4. I don't really care which one you use, but be consistent. Don't use 2 spaces someplace, 3 spaces other places, 4 spaces other places. Don't write code that looks like, don't write code that looks like this. Be consistent. Here's all kinds of inconsistency about where braces are, how much indenting there is. Nobody will want to read. If you have a job and you hand people code that looks like this, they'll just throw it right back at you. Nobody will read code that's inconsistent. It's too hard. It's just too hard to read. Okay, so consistency is the most important thing. Whether you want to use 2 spaces, 3 spaces, or 4 spaces indenting is as important as being consistent. Whether you want to put your braces that way or that way isn't important as long as you're consistent. Okay? Okay. All right. And actually, my preferred, I write all my code with 3 spaces of indentation, and I make the opening and closing brace align with each other. So, and that's I wouldn't be surprised in the future if this becomes the preferred style, though it's in the minority right now. Right now, the majority is still this one. That's still the majority. But it is a little bit harder to read. And the motivation for it is long gone. The real motivation for this was save space on the screen. And modern screens are so huge that saving space on the screen is way less important than making your code more readable. Making it easier for other people to read your code is way more important now. Okay. All right, that's a good question. Style is real important. As you learn to program, you'll see people argue about style a lot. Style is important because style makes code more readable. It makes it easier or harder for someone to read your code. So style is really important. Like not using variable names like X, Y, and Z, unless you have a really good reason to use X, Y, and Z, like you're doing three-dimensional space. But don't just say X is the cost of something, and Y is someone's address, and Z is their first name. Use that's part of style. Java doesn't care if you call something X, but when someone's reading your code, they would really like to see a variable name like price, not X. They'd like to see a variable name like name or last name.
I have a question. Does this program loop or no?
No loops. We haven't talked about loops. You're only supposed to use what we've talked about, variables. Okay?
How did you get it under 300?
By being clever.
You didn't
By
use a
using
loop?
lots of variables in clever ways.
You didn't use a loop?
Can we use a method?
No, variables. That's all we've talked about is variables.
Wait,
That's part of programming is it's a challenge to think real, like, you know, I got it to almost 220 bytes by being very careful of what I gave my variable names to. So I looked at this program and I thought about it quite a bit, and I was very careful about what I named and how I used names. And by being real careful just with naming, I was able to get it down to 220 bytes, 220 characters. Okay. Actually, if you wrote it with loops, I think it would be longer. I think my version with just variables is shorter than one with loops would be. Okay. So
do spaces count as characters?
Yes, definitely. Yeah, space. Yeah, see all these spaces, they count over here. Yeah, they count. So when Windows is like when you ask Windows how long is this file, it's counting every single character in the file. So yes, these spaces count. That's why if you want to make it really short, you get rid of the spaces. That's why you make it unreadable to make it really short is by getting rid of every space that doesn't have to be there.
We're trying to make it below 600, right?
Pardon me?
And we're trying to make it below 600.
Yeah, but then you should add these spaces. To make it below 600, it should be still properly formatted with indentation. The version that's less than 600 characters will still have proper indentation. Okay, that's mentioned in the homework assignment. You will still make it readable. So your version called homework 2 that's supposed to be less than 600 characters should still be readable like this. It'll still be a readable file with proper indentation. Okay, it will still it'll have your name at the top. It'll have all this. So you're kind of wasting space here, but you're wasting space to make it readable. That's why I gave you 600 characters. I'm accounting for the fact that you need to waste space on readability. Then the version that says don't waste space on readability, just see how small you can make it. That's this version here. This is the version that doesn't have to be readable. So this one you get rid of all the spaces that you can get rid of, and anything else you can do to make it as small as possible. This one only has to be less than 600 characters, but it does have to be still readable. Okay, and it shouldn't be that hard. Again, you definitely want names for the big chunks that are like, there should be a name for that. There should be a name for that. You probably want a name for that line because that line gets used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times up here. So you probably want a name for that line there. But that line is really made up of 2 copies of this thing and 1 copy of these spaces in between. So you think about it. You'd have a variable that represents this line, but it should be made up of variables that represent this used 2 times and this used 1 time. So you'll build this variable as something like an A plus a B plus an A. You know, it'll be something like that. This string here will be the beginning part, the middle part, and the right-hand part, but the beginning part and the right-hand part are the same thing. So A could represent that. Well, it's used again here. And B could represent this. And then maybe I call this guy C. But now this guy C, this guy C, this guy C, this guy C. See, I can use C over and over and over again. Okay, so by naming things, I could make my program much shorter than what this is. No loops, no procedures, just really well chosen names. Think about where something is built up out of other things. Just like over here, greeting, you know, when I said hello there, Bob, and hello there, Alice, and hello there, Jane, I really was doing 2 things. The greeting and then the name of the person. So I abstracted out the greeting. That made things better. I need to think about how this was put together. It was really two things, a greeting and a name. And you go over here and you say, well, okay, how is this thing put together? What are all the ways that, well, it's put together as two big blocks. That big block is a copy of that big block. So it's put together as two big blocks. But this big block is, well, there's a line here that gets used over and over and over again. That's a sub piece. It gets used over and over and over again. It's made up of two things that look alike. That guy there and that guy there look alike. This line here looks like almost, well, this line here looks a lot like this line here. They have a different middle part, but they have the same part over here, over here, over here, and over here. So you're looking to abstract out the common pieces. This is what programming, it's a huge part of programming. Abstract out what's appearing in more than one place and give it a name. This appears in several places, give it a name. This appears in many places, give it a name. This line appears in many places, give it a name. This block appears in two places, give it a name, so you can use the name twice. Okay, that's the goal of the assignment. Figure out how to name things. Just use variables. Okay. All right, and it shouldn't be hard to get this under 600 characters. Just naming the obvious big things. You know, you save a lot of space by giving a name to that line and then using that name over and over again. You save a huge amount of space that way. Okay, so that's probably where most of the space savings comes from, is just giving a name to that line, which is used 12 times. Okay. All right. So that's the homework assignment. It's practice in thinking abstractly using variables. And then as we go through the course, we'll learn other ways to think abstractly. We're going to learn loop abstraction, procedure abstraction. You know, those are the two other, and then class abstract. We're going to learn essentially variable abstraction, loop abstraction, procedure abstraction, and then class abstraction. Those are the four ways of lumping things together in programs. Variable abstraction is the first one. That's the very first one we learn. And then as we go through the course, we'll learn more of these. Okay. All right. Any other questions about the homework assignment? You haven't thought about it much yet, so you'll have more questions as time goes on. But anybody got a quick question so far about the homework assignment?
Can we quickly review how exactly the assignment is turned in? Isn't it? It's just the Java file in a zip folder. It's the Java file, the compiled like .class file, and then,
no, I don't want the class file.
Okay.
So for like this homework assignment, what you'll send me. Okay, so I create a folder called home CS3 CS123 homework to craft. That's me. That's my folder. Okay, and in that folder, in that folder, I'll put what'll be homework 2, and you're also supposed to turn in this short one. You're supposed to put it in 2 versions. You're supposed to send me your your medium length one and your short one. Okay, then you'll select these files, right click, and where is it? Send to compressed.
Do we need a screenshot for this one?
No. Screenshots were just for the first assignment.
Okay.
I'll never. Yeah, you'll never need to send me a screenshot again.
Is that first assignment due today? Correct.
Yeah. Due this evening. Yeah.
This evening. What time?
Pardon me?
What time?
Midnight.
Oh, okay.
Yeah, it's due at 11:59.
Yeah. Yeah. So notice then this is the zip. Well, notice that the zip file didn't get the right name, so then I have to change it to CS123 homework 2 craft. That's what I upload, and then inside that zip file are the files that you're sending me. Now I can't show you what to do on Brightspace because I can't log into Brightspace as a student. You know, that I can't really show you what I wrote. I gave you a link to a video. If you go to the homework page, there's this page on turning in your homework assignments. I wrote a paragraph describing my description of what to do, but here's a video that the Brightspace people created. To hopefully, yeah, I think that video is pretty good. It's not very long, and it shows you what to click on in the Brightspace interface. I can't step you through that because I can't log into Brightspace as a student. I can only log into Brightspace as a professor, so I can't show you what it looks like from the student's point of view. It's kind of a fluke of these course management systems. I can't see what you see on Brightspace. I can only see it from my point of view, the professor's point of view. And every once in a while that causes confusion. So if anything looks, if you ever are confused by something, let me know, because yeah, I don't see what you see on Brightspace and you don't see what I see on Brightspace. I see it from the professor's point of view. Okay, so this video should be from the student's point of view, so it should give you a sense of how to upload. Okay.
For the assignment that's due tonight, what type of file do you want the screenshot itself? Like, do you want it to be a PDF, JPEG,
PNG. Here, see, here's Dr. Java. I'm going to do a screenshot. I do a screenshot by holding down the Alt key and typing print screen. The best way to save your screenshot is to go up here and type paint. Windows Paint program will paste your screenshot, and then it saves things by default as PNG. Okay. And that's a real good format. PNG has become the best way to send, when you want to send pictures to people, PNGs become a really good way to send pictures. PDF is good for sending documents. If you're sending screenshots and pictures, PNG, portable network graphics, it's a really good one. And that's what Paint uses by default. Paint saves things as PNG. And in this case, it should be titled, for the homework assignment, it would be homework1.png. You know, save it on your desktop. You can close Paint. So just use PNG because that's what Paint defaults to. Okay. All right. And remember, your screenshots I can't show you because it's on my computer, but you hold down the Alt key and you type the print screen key, then start Paint by just clicking on the Windows menu, type the word Paint, and it'll find the Paint program for you. Click on Paint. See, when I type those key, Alt print screen, that copies the print screen into the paste buffer, and then this one pastes it into Paint, and you can save it. Okay. How about other questions? Any other questions at all about today's homework assignment or the new homework assignment? Anything? Okay, let's see. Let's go back to the course website. What I want to do is look at these go over some of the stuff in these readings. Okay. Now, we have two textbooks for this class. One textbook is really well written and has some homework problems built into it. The other textbook doesn't have as much writing, but it's got a huge number of problems in it, and that's what I like about it. So this is the book that has lots of problems in it, and I think these are very good problems. So the other book is good for explaining and reading and just explaining things, and it's got some problems built into it. This one maybe doesn't quite explain as much, but it asks you to think about what you're learning about. So it's got lots of problems, which are really good. Okay, so I wanted to show you kind of the idea of these. So for example, here's a problem. It's a multiple choice problem. It's about types. What type should be used to represent the average grade in the course? Well, could you use int to represent an average grade, or double, or Boolean, or string? Okay, oops, I don't know what that was. Okay, now think. Could you use an int to represent an average grade? Okay, well, if you just say check me, they'll tell you no, that's not the right answer. Because if you're averaging scores like 5 and 6, the average would be 5.5. So you can't store 5.5 in an int. So int's not a good choice for holding an average. Okay, if you click on Boolean and click check me, it tells you again, well, Boolean only holds true or false, so you can't hold average in Boolean. And then you know, now notice that when you say check me, they give you a reason why. This is what's good about it. They want you to think about a problem, pick an answer, read what they say. If you get the wrong answer, they give you a reason why it's a wrong answer. They give you a little bit of explanation. Now, double is the right answer, because if you're averaging numbers, the answer could be any kind of a decimal number, so you should use a double to hold the average. Okay. Like, here's another one. What type should you use to represent the number of people in a household? Well, okay, int's a good answer because there's a round number. You don't have 2.5 people in a household. But look about double. Here's an interesting. Could you use double? Now, they say, can you have 2.5 people in a household? No, but you can have 2.0 people in a household. You could use double, okay? But it's not the best answer. Int is the best answer. Now, what about string? Click on check me, see what they say. You can use string as a number, but it's not a good idea. For example, suppose there's 3 people in the household. You could store the string, quote, 3, quote. That would represent 3 people in a household. But you can't do arithmetic with that. You know, it's not a really good way. So they point out that you could use a string as a number, but it's a bad way to do things. Now, it's funny that they didn't accept double. Now, you notice that they say for string, you could use a string, but in double, even though you could use a double, because 2.0 or 3.0 is a number of people, you know, the trouble with double is it could give you could store wrong things in a double. There aren't 2.5 people. So string is not a great answer. Double is not a great answer. The best answer is int. Okay? And notice that they give you explanations. So when you're going through here, there is a right answer, but more often than not, when you pick a wrong answer, they give you a little explanation of what's wrong with your wrong answer. Like, what type would you hold the first name of a person? Well, a name is a string. There really is no good reason. You could never use an int. You wouldn't be able to use a double. So there's no really, they don't even really say anything here. It doesn't make sense to try to hold a name and enter a double. So the right answer is string. Okay. Here's another kind of problem. Here's a fill in the blank problem. What type should you use for the number of tickets? Okay, well, you wouldn't use Boolean. You're supposed to type a type in here. Now, you wouldn't use Boolean for a number of tickets. You could use double, but that's really not so great. There aren't 2.5 tickets to a show or 3.25 tickets. Tickets come in whole quantities, so the best answer. Now, let's see what they say about check me. See, now notice that you really could use double. They don't point that out. They just say, you know, that's not the right answer. You want to represent whole numbers, so the right answer is to type in the type int. Okay. So this is one kind of problem. They have multiple choice problems, fill in the blank problems. You're not being scored on any of this. There's no keeping record here. This is really, the purpose of it is to give you something to think about as you're reading Java. Java's not an easy thing to learn. These are good questions. If you answer these questions and think about them, you'll gain a lot of knowledge. You really will gain a lot from doing this. Later on, they have problems where you have code. They have actual code problems. First of all, let's look at this problem here. Before we do a code problem, click on, what this problem does is let you click on lines. When you click on a line, the line gets highlighted or unhighlighted. So here I unhighlight. The problem is click on the variable declarations. Like this line here is a variable declaration. This line here gives it a value. It's not a declaration. This line here declares a variable, and this one gives it a value. And then again, this one declares the variable, and this one gives it a value. So I click on the lines that I think are the declarations, and I say check me, and I'm correct. Now, if I made a mistake, this is not a declaration. The declaration is the line above it. This gives the variable a value. Then it tells me I made a mistake. Notice that the correct one stays highlighted. The incorrect ones kind of get boxed in. Okay, so these are good problems. That, you have to think a little bit about reading the code. You're asked to read the code and answer a question about it. This one asks for the initializers, not the declarations. This one asks for the initializers. So for example, this one declares a variable. That's not what it wants. It wants the initializer. Now this line declares and initializes, but they want the initializers clicked on. So you click on that one. This one's only is a declaration. This one's initialization. This one is a combination of declaration and initialization. Again, this one here is a combination of declaration and initialization. This one down here is not initializing, it's changing the value of a variable. This one's initialization means giving it its first value. So here you declare the variable with no value. Here you give it its first value. Here you declare the variable and give it its first value. Give this variable its first value. This changes the value. So check me, correct? Notice if I click on this one, because it looks a lot like that one up there, see? But this one's going to be wrong because that's not initialization, that's updating. This is initialization. So these problems help you start learning the vocabulary, the way to think about programming. Okay? Here's another kind of problem. In this problem, you've got code on the left, and you're supposed to drag the proper lines in the right order into the right-hand side. So they tell you what they want, and they give you code over here, and your job is to look at what they gave you. Not everything they gave you on the left is what you want to use. You have to figure out which lines of code over here to drag over to here and in what order. They want code to initialize variables for the number of visits, a person's temperature, and whether a person has insurance or not, in that order. Number of visits, temperature, insurance. Okay, now, number of visits is down here. Now notice that they have two versions of it. Which one of these is the right one? Int num visits 5, int num visits 5. Which one's right?
Two A.
2A because what? What's wrong with this one? What's wrong with 4A?
It's capitalized.
Yeah, you're not supposed Java, everything is case sensitive. You don't capitalize the I in int. That's wrong. If you used 4A, you'll get an error message. So that's the first line of code they want. Int num visits it's 5. Then they wanted temperature. Notice they did the same trick here. They capitalized the D. That's not what you want. You want the lowercase d. That's the proper declaration. Then here is whether they have insurance or not. Okay, now I think that's the right code in the right order, and I say check me, and I got the right answer. Now notice if I put things in the wrong order and I say check, oh, I have to reset it first. Okay, first I have to reset it. Now let me do things in the wrong order. There's the right code in the wrong order, and notice it kind of points out that this one's in the wrong order. Okay, so I have to move this one to get it in the right place. Num visits was supposed to be first. Then I can say check. Okay, what if I choose one of the wrong ones? So visits, temperature right, has blue. Okay, now what I made a mistake here is I used one of the declarations with a capital I. If I say check, again, they say that one's wrong. Okay, now in this case, that's the wrong block. It's not in the wrong order. It's actually the wrong block. I'm supposed to get rid of that block and put, which one was it? Yeah, this one here up there. Then I can check and I'm right. Okay, so these are good problems. Okay, this is the last kind of problem, a code problem. Okay, where there's actual code. Okay. Oh, well, actually, no, this isn't a problem. This is just, they just want you to see what this program does. Let me find one that's actually a problem. Okay, here's a problem. Add a print statement to concatenate the string literal favorite color is with the stored value of color. So see, they stored a color string. They've stored a string in a variable called color. And they want you to print out favorite color is red. Okay, so they want me to do system.out.print line. And I'm supposed to print out the message favorite color is. Then I'm supposed to say, well, what's the favorite color? But the favorite color has been abstracted into a variable, so I'm supposed to use the variable. What I'm not supposed to do is say is red. See, now, notice that this is going to output favorite color is red, but that's not what they want you to do. They want you to use the fact that red has been abstracted. If I run this, it's compiling. Now, my output is right, and I did get the right output. See, pass in green, I got the right output, but I failed something else. I didn't use their variable color. So when you have a programming problem in here, your code goes here, your output shows up here, and when you run it down here, you get a little box that says what you passed and what you failed. Okay? Now, I failed because I didn't use their variable. I should have done this. Favorite color is, now to add on the abstracted variable. Remember, this is very much like what we did last week when we did the greeting. This is like a greeting, and then this is something where, and here's the opposite. The color has been what's abstracted. So favorite color is, but notice that this variable is holding part of the message, but the part of the message has been abstracted into a variable. Now, if I run this, it compiles it, runs it, and I passed it. Okay. Now notice that there's another box here that says show code lens. If you click on that, you get a box that's going to be below here. And this box should look familiar. This is the Java visualizer, but they don't call it the Java visualizer. They call it the code lens. This is going to help you if your program doesn't do what it's supposed to do and you're not sure why. Like I said before, the Java visualizer, or what they call the code lens, lets you step through your code and watch what it does. Okay, so for example, it creates a variable called red, and then it's going to print the output. Notice that just like the Java visualizer, your code is here, your output is here, your variables are here. Down up here, you have just code and output, and then whether you passed. What you really want is also the variables. That's what the code lens does. It shows you the variables, just like the Java visualizer. So the code lens actually is the Java visualizer embedded into their book. So they learned how to take the code of the Java visualizer. You can actually take the code of the Java visualizer and you can embed it into other websites. See, they have a trick here where you can generate, this is what lets you embed the Java visualizer into other websites. See, they generate a URL that you can use. Okay, so they've got the Java visualizer. I don't know why they gave it a different name, but for some reason, the people who wrote this book called it Code Lens. Then you can hide it, because you don't always need it. So when you hide it, it's not there. If you want to use it to debug, to figure out what's going on, you can show it. Okay, and then whatever code you have up here is copied into the Java visualizer down here. Okay, so that's what they have here. They have several kinds of problems. The hardest problems are the actual coding problems, and the easier ones tend to be the multiple choice and the fill in the blank. Very good problems are these ones that have you read code and pick lines of code. These are really good problems. They really actually make you think hard about programming. For starting out, these are very good problems. And so are these ones that have you arrange lines of code. There's lots of these kinds of problems in the book. They're very good problems. They really help you get started with thinking about Java programming. And then they have the hardest problems are ones where they actually want you to write code, where they give you a little problem description and say, do something with this code. And then you have to type the code yourself, run it, and see if you pass their test. Okay? All right, let's look at another. Okay, this was section 1.3. You also had a reading assignment to look at 1.4. Let's look at, I want to just skip ahead to one section here, 1.4. we talked last week about the integer division versus decimal division. Okay, and I want to show you. They talk about that a little bit. Just keep scrolling down. It's somewhere here. The modulo operator. This is where they talk about these two different kinds of division. Okay, I want to show you an example of where this division can come up in. Like somebody asked last week, like when would you use these funny kinds of division? So let me show you like a nice example. I'm going to do it over here in the Java visualizer. Okay, so I'm going to write some code over here in the Java visualizer. Suppose I have suppose somebody has 197 pennies. Here's a problem. How many nickels, dimes, and quarters would you give somebody to replace their 197 pennies? It turns out that these funny division operators can solve this problem for us. Okay, so how many quarters are in? How many quarters are in that many pennies? What I'm really asking is, in this many pennies, how many times does 25 go into that many pennies? See, that's the integer division. The division that your calculator doesn't do. And this is a good example of where I would want it. I want to know how many quarters are in 197. Now, I kind of know what the answer is. It's what is it? 7 quarters. Okay, there's 7 quarters in 197 pennies. But I can figure that out by just thinking how many 25s can I put in 197. Now let's visualize this. Okay, I've got 197 pennies, 7 quarters, because I asked how many times does 25 go into pennies. Okay, now I want to figure out what to do about nickels and dimes. Okay, now let me make this number a little bit larger. Let me make this like 117 pennies, so I have a little bit more to play with. Okay, in 117 pennies, no, I'm sorry, I want 217 pennies. Let's try two. What would be a good number? No. Actually, that's a real good 199. 7 quarters. How many pennies are left over? Well, we know how many pennies are left over, but how does Java figure that out? When you ask how many 25s that are in their pennies, then you want to know how many pennies are left over so you can start figuring out how many nickels and dimes there are. So now I use another division operator. I want the change left over. The change left over is you take pennies and you ask not to divide it by 25 like we just did. Use this other operator which asks for the remainder. When you divide 25 into pennies, we know that there's 7 quarters and there's going to be 24 pennies left over. That's the remainder. So the quotient is 7 and the remainder is 24 pennies. So now if I visualize this, whoops, what did I do wrong here? Oh, I forgot the equal sign. $199 pennies is 7 quarters with 24 pennies left over. Now with that 24 pennies, I want to know how many dimes go into it. So now I'm going to do this, int dimes. Well, what I want to do is I want to take my change and ask how many 10s go into the change. A dime is a 10. How many dimes are there in that change? That's the integer division again. Okay, and this one was what we call the modulo, which is the same thing as remainder. You're not in school, in school they never call it modulo. but programmers call it modulo. In school, you were taught to call it the remainder. So you might need to remind yourself that when you see, like here, they say modulo or remainder. Remainder is the term that everybody was taught in school, but programming languages always refer to it as modulo. Okay, that's just a fancier word for remainder. Okay, so this is integer division if there's integers on both sides of it. It's regular division if there's double decimal numbers. This is remainder. Now, I want to find how many dimes I go into there. Okay, so now I go visualize. I can see, well, 199 pennies have 7 quarters, 24 pennies left over, 2 dimes. Okay, now I want to know how many nickels go into that. I should do nickels after I do dimes. Okay, well, first I need to know the change left over. After I ask how many dimes there are, I'm going to call it change 2. This is how many pennies are left over after I take out the dimes. Okay, so that would be the original change modulo 10. Okay, so this is how many pennies are left over after I ask how many dimes go into it. So just double check. 7 quarters, 24 cents, 2 dimes, 4 pennies left over. Okay, now if I wanted to know nickels, I would say int change 2 divided by 5. How many nickels are there in that change? Well, nickels did I spell that right? How many nickels are there after we take change 2? Oh, I'm sorry. Yeah, change 2. Get confused. So change 2 has how many pennies are left over after you take out the dimes. The nickels will be how many 5s go into change 2. Now in this case, there's going to be no nickels. Okay. If I change my number up here a little bit, if I go down here like to 191. $191 has 7 quarters with 16 pennies left over. 1 dime goes into 16 pennies with 16 pennies left over, and 1 nickel goes into 6 pennies. And then the last thing would be how many pennies are left. Okay, then int change 3, that's the last number of pennies. This is going to be change to modulo 5. Okay. And I can just go skip here to the end. So 191 pennies had 7 quarters with 16 pennies left over, but there's 1 dime with 6 pennies left over, and then there's 1 nickel with 1 penny left over. And you can try different numbers. Let's try 196. 7 quarters with 21 pennies left over. That's 2 dimes, no nickels, and 1 penny. Okay. Notice how useful this. Now, this is a classic example of how these 2 different divisions, the integer division and the modulo division, the division and remainder, how they can be used. You want to chop a big number up into pieces. This happens a lot in programming. You've got some big, here I want to chop it up into 25s, 10s, and 5s, find out quarters, nickels, and dimes, and pennies. And there'll be other times when we want to chop up a big number in smaller numbers. And the modulo, this is what it's there for. The modulo, the quotient and remainder are there for when you want to chop a big number into smaller units of some kind. For example, suppose I tell you I have something that's 173 inches long, and I want to know how many feet it is. That's a good question. I want to chop 117 inches. I can do the same kind of thing here. I could start another problem. I could say int inches equal, say, 178 inches. And then int feet. Well, feet is going to be, how many feet are in 178 inches? It's inches divided by 12, and then int inches 2. How many left over is the original inches modulo 12. So this would tell me how many feet are in that many inches and how many inches are left over. Okay, 178 inches was 14 feet with 10 inches left over. Notice how useful integer division and modulo can be. It's for chopping things up. So here I'm finding out how many feet and inches are in a certain number of inches. I could do yards, I could do centimeters. Well, centimeters is different. This is not a conversion. So converting inches to centimeters is not this kind of problem. This is asking how many feet does this number of inches chop up into. Converting inches to centimeters is a multiplication problem, not a division problem. Okay? All right. So this is a prime example of why we need in a programming language these other kinds of division operators. Your calculator has, I mentioned, your calculator does the regular division by default. These other division operators, they're in your calculator, but you have to press special buttons to get them. Okay, we've run out of time. I'll save this example. I'll put it up on the website. Like, notice that this is example. We did it in the Java visualizer. What I'm going to do, I'll show you real quick. I generate a URL to it, and then I put that URL into the website, and then I have a link to this example on the course website. So you'll see a link to this example on the course website because I can make, it is a web page, so I can go down here and I could cut that URL. In fact, I can open another browser here. If I paste that URL in here, you see that there's my code. That URL saved my code. If you go here and if you look, you can kind of read the code. It's buried. The code is buried in that URL. The actual Java code has been buried in the URL. That's an interesting way to do things. Okay. And then you give that URL to the browser and it goes to the Java visualizer and it shows you your code. So that's a real convenient way to do things. You can send code to people this way. Okay. Well, I'll use it to put this code up on the course website. There'll be instead of there being a link to a Java program that's a file, sometimes I'll have a link to Java programs on the Java visualizer. Okay. Any last question? We've run out of time. We've gone over a little bit. Anybody have any last question about what we've been doing?
Yeah, I've been trying the homework too, and I can only get it down to 1,000 characters.
Oh, keep trying. You got 10 days. So that's a good start. Yeah, that's a good start. Think a little bit more about it. That's a pretty good start. You're halfway. You're getting close. Look for things you can give names to. Look for something that's used more than once in the output and that you can give it a name. Try to find more names. The answer is try to find more things you can give a name to. Okay? And try to reuse, try to use those names over. If you use a name only once, that's usually not a good thing. You're looking for something where you can give it a name and then use the name 2 or more times. Because every time when you use the name for the second or third time, that's when you're actually saving space. So look for things that are used over and over again that you can name. Little things and big things both. The little things become parts of the definition of the bigger names. So you got plenty of time. Keep trying. You've got a good start. Keep. I bet you.
I figured it out.
Okay.
Thank you.
Yeah, fine. You just keep looking for something you can give a name to. What about other questions? Anybody got any other questions about what we've been doing so far? Read the course material and please do the exercises that are buried in here. I think that's the most important thing to tell you is to do all these exercises. They are they're your main homework actually, and they will get you thinking about Java. This stuff is pretty well designed. The person who wrote this book actually I can give you to illustrate. The person who wrote this book is a woman who does research in how to teach. She's a university professor whose research is entirely on how to teach programming. That's all she does, is she thinks about how to teach programming. And she's come up with, she's the one who actually invented a lot of these ideas, like these problems about dragging things around. She's come up with a lot of these ideas. I think it's very good stuff. I think it really helps. She's put a lot of thought herself into how to teach programming, and this is the result, and I think it works pretty well. And you couldn't do this with a traditional book. You couldn't do this 10 years ago. You couldn't do this until things became websites. So she said, well, once things are websites, why can't we make the books way more interactive? And that's what she's been working on. And this is what it looks like. So I think it's really good. Go through and do these problems. I think they'll help you a lot. Okay, any last question? Any more? Okay, if you have questions, you can send me email. You can do a Zoom meeting, or you can just send me an email. I'm going to stop sharing, and I'm going to go ahead and end the meeting for all, and see you on Thursday. Bye.